Mathematics is not merely a subject taught in schools. It is a universal language, a framework of logic and abstraction that has shaped the course of human history. Its origins stretch back to a time before written language, organized religion, or agriculture. It emerged organically from the human need to understand, quantify, and manipulate the world. From the earliest tally marks carved into bones to the sophisticated algorithms powering artificial intelligence, mathematics has evolved alongside humanity, reflecting our deepest curiosities and most ambitious aspirations. Long before civilizations rose, early humans engaged in rudimentary mathematical thinking. Archaeological finds such as the Lobombo bone and the Ishango bone suggest that prehistoric people used tally marks to count days, track lunar cycles, or record quantities. These artifacts represent the earliest known attempts to impose order on nature through symbolic representation. Mathematics in this era was deeply practical. It helped early humans track time and seasons for hunting and gathering, count possessions or members of a group, and recognize patterns in nature, such as animal migration or celestial movements. This intuitive grasp of quantity and pattern laid the groundwork for more formal systems that would emerge with the rise of settled societies. With the dawn of agriculture and urbanization around 3000 BCE, mathematics became indispensable. In Mesopotamia, the Sumerians and Babylonians developed a base 60 number system, which still influences how we measure time and angles today. Clay tablets from this era reveal advanced calculations in geometry, algebra, and even early forms of trigonometry. In ancient Egypt, mathematics was used to survey land after Nile floods, construct monumental architecture like pyramids, and manage trade, taxation, and resource distribution. Egyptian mathematics was largely arithmetic and geometric, recorded in texts like the Rhind Mathematical Papyrus and the Moscow Papyrus, which contain problems involving volume, area, and proportions. Meanwhile, in the Indus Valley Civilization, standardized weights and measures suggest a sophisticated understanding of mathematics, though much of their written record remains undeciphered. The Greeks transformed mathematics from a utilitarian tool into a philosophical pursuit. Around 600 BCE, thinkers like Thales of Miletus and Pythagoras began exploring mathematical principles as eternal truths. Pythagoras believed that numbers were the essence of all things, and his school laid the foundation for number theory and geometry. The pinnacle of Greek mathematical thought came with Euclid, whose work, Elements, systematized geometry into a logical structure based on axioms and proofs. This approach introduced deductive reasoning, which remains central to mathematics today. Other Greek contributions include Archimedes, who calculated areas and volumes using methods akin to integral calculus, Apollonius, who studied conic sections, and Hipparchus and Ptolemy, who applied mathematics to astronomy. Greek mathematics emphasized proof over computation, a philosophical shift that would influence centuries of mathematical development. In ancient India, mathematics flourished with profound innovations. The concept of zero as both a placeholder and a number was formalized by scholars like Brahmagupta in the 7th century CE. Indian mathematicians also developed decimal place value notation, algebraic methods for solving equations, and trigonometric functions and identities. Texts like the Aryabhatiya and Lilavati reveal a deep engagement with astronomy, geometry, and arithmetic. In China, mathematics was applied to engineering, surveying, and calendrical science. The 9 chapters on the mathematical art presented methods for solving linear equations, calculating areas, and managing logistics. Zhu Shiji later advanced algebraic techniques and introduced symbolic notation. These civilizations emphasized computational efficiency and practical application, complementing the Greek focus on abstraction. Between the 8th and 14th centuries, the Islamic world became a hub of mathematical innovation. Scholars in Baghdad's House of Wisdom translated Greek, Indian, and Persian texts into Arabic, preserving and expanding upon them. Key figures include Al-Khwarizmi, the father of algebra whose name gave rise to the word algorithm, Omar Khayyam, who solved cubic equations geometrically, and Al-Tusi, who refined trigonometry and developed spherical geometry. Islamic mathematicians introduced systematic approaches to algebra, geometry, and number theory, and their work laid the foundation for the European Renaissance. During the Middle Ages, mathematical progress in Europe was limited, but the translation of Arabic texts in the 12th century reignited interest. Fibonacci introduced the Hindu-Arabic numeral system and the famous sequence that bears his name. The Renaissance saw a surge in mathematical creativity. Descartes developed analytical geometry, linking algebra and geometry. Kepler and Galileo applied mathematics to physics and astronomy. Newton and Leibniz independently invented calculus, revolutionizing science. Mathematics became central to the scientific method, enabling precise modeling of natural phenomena. The 18th and 19th centuries brought deeper abstraction. Euler advanced graph theory, complex analysis, and topology. Gauss explored number theory and non-Euclidean geometry. Cantor formalized set theory and the concept of infinity. In the 20th century, mathematics underwent a formalist revolution. Hilbert sought to axiomatize all of mathematics. Gödel proved that no system could be both complete and consistent. Turing laid the groundwork for computer science and artificial intelligence. Mathematics became increasingly specialized, branching into fields like topology, category theory, mathematical logic, computational mathematics, and chaos theory. Today, mathematics underpins nearly every aspect of modern life. Algorithms drive search engines, social media, and e-commerce. Cryptography secures digital communication. Statistics inform public policy and scientific research. Mathematical models predict climate change, pandemics, and economic trends. It is the language of science, the foundation of technology, and the architecture of modern civilization. The advent of mathematics is not a single moment, it is a continuous unfolding of human insight. It began with survival, grew through necessity, flourished through curiosity, and now accelerates through innovation. Mathematics is both ancient and futuristic, simple and profound. It is a mirror of human thought, a tool of discovery, and a bridge to the unknown. As long as humans seek to understand their world, mathematics will evolve, forever expanding the boundaries of what is possible.